Finally, we get to section 6.5, the wrap-up. In this chapter, we looked at the intrinsic calibration for a single camera. We began with the idealized pinhole camera model, and we began by presenting the coordinate setup. Then we looked at two-dimensional and three-dimensional relationships between the image plane and the object in 3D Cartesian space. At the end, intrinsic calibration was the mapping from 2D image space to 3D Cartesian space. After that, we introduced distortion, which occurred when we began to consider lens. And we saw that the distortion model is primarily a polynomial function based on the radius of the lens. After that, we looked at the intrinsic calibration of the stereo cameras. Here, the situation is we have two cameras, so we can do two individual intrinsic calibration routines, but then we need to compute the rectification of the images to assume they are parallel to one another. Once the images are rectified, we need to extract the baseline between those rectified images before we can then infer 3D coordinates for points of interest. Finally, we introduced OpenCV and ROS, and we used a different textbook for that, ROS by example, and we learned about the OpenCV bridge as the main method to transform ROS types and OpenCV types in either direction. We also learned some of the OpenCV basic routines that helped us to do edge detection, color extraction, and face detection.